Hey everyone, welcome back to Astronomy Daily. And if it's the weekend where you are, welcome to a slightly different edition of the show.
This is the Weekend Wrap. Same show, same us, same runtime, but on the weekend we're doing things a little differently. One fresh lead story you haven't heard from us yet, and then we round up the big stories from the week in case you missed any of them.
It's Saturday, August 15th, Series 5, Episode 168. And it has genuinely been one of the biggest weeks we've covered in a while. Total eclipse, triple black holes, a black hole hiding inside a star, a rocket possibly lost at sea. So today we're going to do two things.
First, a brand new story that landed just yesterday. Physicists may have finally confirmed something Werner Heisenberg predicted 90 years ago about empty space not actually being empty.
Which is a great one to lead with because it's the kind of story that would have been our Tuesday or Wednesday main story any other week. It's just that this week had a lot of competition.
Then we're going to run back through the week. An update on Starship, which we told you Monday might be lost at sea, the black hole star we covered yesterday, Tuesday's eclipse, and Virgin Galactic's rough few days.
Lots to get through. Let's get into it. Okay, so this story starts in 1936, which is a very unusual place for us to start.
Very unusual. Take us back.
So in 1936, the physicist Werner Heisenberg and his student Hans Euler proposed something that sounds like science fiction, that empty space isn't actually empty, that what looks like a vacuum is really the simmering sea of virtual particles, electrons and positrons flickering in and out of existence for fractions of a second.
Which already sounds made up.
It does, but it follows from quantum theory. And here's the testable prediction that came out of it. If you put that empty space inside an extraordinarily strong magnetic field, light passing through it should get polarized in a specific direction, an effect called vacuum birefringence. Basically, the vacuum itself starts behaving a bit like a lens.
And the problem, I'm guessing, is that nobody's ever been able to build a magnetic field strong enough to actually test that.
Exactly the problem. We're talking about a magnetic field more than 100 million times stronger than anything we've ever produced on Earth. So for 90 years, this has just sat there as an untested prediction of quantum electrodynamics.
Which is where the magnetar comes in.
Right, because it turns out the universe has already built the lab we needed. There's a magnetar out there, a dead star called 1E1547-5408, thousands of light years away, and its magnetic field is easily strong enough. A team led by Rachael Stewart, a physics grad student at George Washington University, used NASA's IXPE spacecraft, that's the Imaging X-ray Polarimetry Explorer, to check.
And IXPE's whole job is measuring polarization.
That's exactly its job. It launched in 2021 specifically to measure how polarized high-energy X-rays are. Stewart's team pointed it at this magnetar in March and April of last year and backed that up with observations from the International Space Station, Australia's Murray-Yang Radio Telescope, and the South African Radio Astronomy Observatory.
So what did they actually find?
Two things that together made a pretty compelling case. First, the X-rays coming off this magnetar were almost 3 times more polarized than standard models of a neutron star's surface could explain on their own. Second, and this is the clincher, the direction of that polarization lined up with the star's magnetic field and matched the pattern they were already seeing in its radio waves.
So it's not just more polarized than expected. It's polarized in exactly the direction the Heisenberg-Euler prediction says it should be.
Exactly. Put those two things together and vacuum birefringence becomes basically the only explanation left standing.
90 years is a long time to wait for a callback.
Really is. And Stewart had a nice line about what this actually means for how we use objects like this. She said, we're not just studying astronomical objects anymore. We're using them to test the laws of nature.
That's a good way to put it. The magnetar isn't really the subject of the study, it's the equipment.
Right. It's a 100 million times stronger than Earth's best particle physics lab that just happens to be sitting out there thousands of light years away. One of the co-authors, Marcus Lower at Swinburne University in Australia, put some scale on that. He said detecting vacuum birefringence requires a magnetic field over 100 million times stronger than any we've ever made on Earth.
So there's no version of this experiment that ever happens in a lab. You need a magnetar or nothing.
Nothing else will do it. And I liked Lower's other quote because it's a nice reminder of what a confirmation result like this actually feels like for physicists. He said it's a bit of a relief because it means that our theories still work and there's nothing broken with physics.
Which is honestly kind of funny. The good outcome here is boring. Nothing broke.
Right. The exciting result would have been actually quantum electrodynamics is wrong, and everyone would have had a much more interesting week and a much worse year. This is the quietly satisfying outcome instead. A 90-year-old prediction just got its first real observational backing.
Where does this go next? Is this case closed or is there more confirmation needed?
More confirmation is very much still wanted. This is a strong first detection, not the last word. There's a future mission called GOSOX that's specifically designed to chase this effect further and nail it down with more precision. But for now, this is the strongest evidence anyone's produced that the vacuum genuinely behaves the way Heisenberg and Euler said it would back in 1936.
And just to place it, this research was published August 5th in Nature, so it's had a couple of weeks to circulate before really breaking into wider coverage this week.
Which happens a lot with these physics results. The paper drops, and then it takes a beat for people to fully appreciate what it means. But once you explain this confirms space itself isn't empty, it tends to land.
It's a great one to kick off the weekend with. Genuinely new physics, using the universe as the lab nobody could ever build.
All right, on to the recap. It has been an absolutely stacked week, so let's go roughly in the order it happened, starting with Monday.
Monday, we told you SpaceX's Starship might be lost at sea, so let's start there with an update, because it's been hanging in limbo all week.
Quick recap for anyone who missed Monday. This goes back to Flight 13, which launched July 24th. The upper stage, Ship 40, did something no Starship upper stage had ever done before. It survived a soft splashdown in the Indian Ocean off Western Australia, completely intact.
Which was actually the good news story originally.
It really was. SpaceX started towing it towards shore in Australia, and for a few days, it looked like they might genuinely bring an intact upper stage home for the first time. But the weather didn't cooperate. Seas got rougher, conditions kept deteriorating, and on August 7th, Elon Musk gave the update we led Monday's episode with. He said ship recovery is not looking good right now.
And where does that stand now, nearly a week later?
Still unresolved, honestly. As of this weekend, Ship 40 remains out there, still afloat as far as anyone's confirmed. But the recovery ship Geo Australis has been holding position near it rather than making obvious progress. Prediction markets watching this closely have it at somewhere around an 18% chance of the ship actually making it back to shore.
So, not officially declared lost, but not looking great either.
That's the honest summary. Genuinely unresolved. The one bit of good news is that SpaceX already got what they really needed from this before the weather turned. Close-up drone footage of the heat shield and engine sections, which is the data that actually matters for building the next ships. So even if Ship 40 never makes it to port, the program's already moved on to the next one.
And life goes on regardless. SpaceX isn't waiting around for a resolution.
Not at all. Ship 41's already working through its own test sequence for Flight 14, which is currently targeting around August 20th. Booster 21's finishing up engine installation for its own static fire testing. And there's repair work underway at the pad after Flight 13. So whatever happens to Ship 40, the program's already moved on to the next one.
We'll keep an eye on it and let you know if there's a final word either way.
Next up, and honestly still probably the single biggest story of the week, Tuesday's total solar eclipse.
We did a full deep dive Thursday, so quick version for anyone catching up. A 182-mile wide shadow swept from the Arctic Ocean down across eastern Greenland and western Iceland, and then out across northern Spain before heading into the Mediterranean.
The longest totality anywhere on land was 2 minutes, 18 seconds at a dramatic bird cliff on Iceland called Latrabarg. Millions of people gathered across northern Spain too, Towns like Valoria Labuina and Segur de Calafell were packed, with totality arriving low on the horizon about an hour before sunset for a genuinely golden, dramatic show.
And it wasn't just spectacle. Observers got a rare direct look at the sun's corona, a solar prominence, and Jupiter, Mercury, and Venus all visible in the darkened sky during totality.
One line from that episode that stuck with me all week: an observer in Spain described it as something that strikes the lizard part of your brain that just tells you this shouldn't be real.
Still the best description of totality we've heard. And if you're already plotting your next one, Spain gets another total solar eclipse on August 2nd, 2027.
Less than a year away, eclipse chasers are having a very good stretch.
Story 3, and this one's fresh, yesterday's episode in fact, so if you're a regular weekday listener, you've already heard the full version. But for anyone joining us just on weekends, here's the headline.
Astronomers using the James Webb Space Telescope found what they're calling a black hole star, BOM-BH-Star 1, out of the Mirage or Miracle JWST survey. It's a young, rapidly growing black hole wrapped in such a dense, turbulent cocoon of gas that the whole object glows, almost like a star, even though a black hole is doing the work at the center.
And it's ancient. The light left it about 660 million years after the Big Bang, roughly 13 billion years ago, making it the earliest confirmed object of its kind.
Led by Rohan Naidu at the University of Hawaii and Yorat Mathy at the Institute of Science and Technology, Austria. And the reason it matters beyond cool, a weird object, is that it might explain a 50-year-old puzzle: how supermassive black holes got so big so early, when normal gas accretion shouldn't have had time to do it.
And it ties directly back to Thursday's story too, doesn't it? The 3 black holes sharing one galaxy.
Exactly the same puzzle from a different angle. If black holes can hit these accelerated growth phases, whether through a gas cocoon like this one, or through merging with each other like Thursday's trio, that gives them a much faster route to becoming supermassive. 2 chapters of the same bigger story, basically back to back.
AJWST just quietly having one of the best months of any telescope ever built.
Last one, Virgin Galactic, and this is a story that actually got worse as the week went on.
We flagged the headline Thursday. Their upgraded Delta-class spacecraft, which was supposed to start flying paying customers this quarter, has slipped to February 2027. The company says they need more time on avionics and systems installation before putting people on board.
Shares dropped about 12% in after-hours trading when that news broke.
And then Wednesday, the company reported its second quarter results, and that's where it got worse. Revenue came in at just $1.54 million, well under expectations, with a net loss of around $55.9 million for the quarter.
The stock fell another roughly 7.7% on that news, and management's now guiding towards some genuinely rough cash burn for the rest of the year. $95 to $100 million going out the door in the third quarter alone, $80 to $90 million in the fourth. They've also filed paperwork that lets them raise capital through stock, debt, or warrants if they need to, which is the kind of filing that exists specifically because a company thinks it might need it.
That's not a great combination. Bigger losses, a slipping timeline, and now the option to dilute existing shareholders if cash gets tight.
It's not, though there is one genuine bright spot buried in there. Their $750,000 a seat flight packages were oversubscribed, and the CEO said they'll be offering higher price points when ticket sales reopen this autumn. So whatever else is going on, demand for an actual seat isn't the problem.
Which is sort of the whole Virgin Galactic story in one sentence at this point. The demand and the money are mostly there. It's the hardware and the timeline that keep slipping.
That's it exactly. We'll keep tracking it as February 2027 gets closer.
Okay, that's the weekend wrap. A brand new story about empty space not actually being empty, plus updates on Starship still adrift in the Indian Ocean, Tuesday's total solar eclipse, yesterday's black hole star discovery, and Virgin Galactic's rough week.
A huge week for space and astronomy news, and hopefully a useful way to catch up if you missed any of it along the way.
If you enjoyed today's episode, the best thing you can do for us is leave a rating or review wherever you're listening and share the episode with a fellow space nerd. Full show notes, sources, and links for every story we covered today are at astronomydaily.io. And you can find us on social media. We're at Astro Daily Pod pretty much everywhere.
We'll be back Monday with our regular weekday updates. Until then, keep looking up. Clear skies, everyone.
See you next time.